No.
Okay, okay, okay. Hmm. No problem, no problem. Very good. Wait. See, we are having the many laws are there actually. So what do you mean by law of chemical combination? Any idea about the law of chemical combination? Any idea?
Sir,
Law of,
means that law of conservation, law of chemical combination, certain laws that govern the chemical reactions.
hmm,
They law of chemical combination. They are combination of elements to form combination of elements to form compounds are
hmm.
governed by these laws.
Oh, okay, okay. They are the group of law. That is correctly you said. So first one that is the already we know this one conservation of mass. Okay. So this law say that is mass can neither be created nor be destroyed. Okay. So first one is conservation of mass. Second one is definite proportion. Okay. This also you must be knowing definite proportion. If you are talking about next one, so that is multiple proportion is there. One more is there. Uh, Multiple proportion. And here if you go, that is one is the fourth one is reciprocal proportion. Reciprocal. This is there in your NEET syllabus. Reciprocal proportion. Okay. And the fifth one we are having Gay-Lussac's law. Okay. Gay-Lussac's law. And last one is the Avogadro law. Okay, Avogadro.
Sir, among these, the fourth one is not in the NCERT. Sir,
A fourth one is not there in NCERT, but it is there in the competitive track is there. Okay. Again, when you study other chapter, it will come the Dalton's law of partial pressure. That will also comes under the.
that is in states of matter.
But in basic concept also we study this one. But let us try to understand. So this one you must be knowing law of conservation of mass.
Yes, sir.
Mass can neither be created nor be
Neither
destroyed.
created nor destroyed in the chemical reaction.
Suppose the compound is there CaCO3. They are saying this is 100 gram. It form that is CO2, and they said CO2 form 44 gram. Then they will ask that is CaO X gram. So they will ask that is what is the value of X. Okay. So according to this, we can be solved only by the law of conservation of mass, right?
Yes.
Huh. How much the value of X you are expecting here?
We will do like 100 minus 44, then we will come, we will have 56.
56 grams. So X is equal to, it is going to be 56 grams. So this we are not telling you because it is very easy. Now the next one is their definite proportion. Definite proportion you also know. Definite proportion. What is the definite proportion? I am giving you questions. Okay. Definite proportion. You explain better. Okay. Definite
A
proportion.
definite proportion means that in a given a given compound always contains exactly the same proportion of elements by weight,
Hmm.
irrespective of the source from which the compound is taken. For example, like if we take water and hydrogen from if we take water from any source like distilled water or tap water, anything, then
Hmm.
then in all cases the ratio of H2O will come 1:8 by
Okay.
mass.
Okay. That is great. So now I am giving you one question. Okay. Let me tell you, you tell me that is what law it is going to follow. Okay. Okay. What law it is going to follow. Okay. This is there. So there are many methods are there for preparation of the what to call that is the any of the compound we can prepare the n number of methods are there. Okay. Not one
Yes, sir.
method. Carbon dioxide we prepared. Okay. By four method. Firstly, what we did, we complete oxidized carbon into carbon dioxide. Then here is partial oxidized carbon monoxide is there. Okay. That is the polytent. Half O2 we taken again the second method. We decompose the calcium carbonate. Again we got CO2. And we burnt the hydrocarbon. Again we got
Combustion of
CO2.
stage.
Hmm. What law it is going to follow?
So definite proportion.
Law of definite proportion, because the ratio by masses are the always fixed. And what will be the ratio? Can you tell me?
The real
Well,
ratio This is 12, this is 32. 12 is to 32 means 6 is to 16, 3 is to 8.
3 ratio 8. This one. Now another one we are going to for the multiple proportion. Let us try to go with the multiple proportion. Here is if you are talking about multiple proportion. Multiple proportion we already study in details earlier. So no need to go for this detail. What this law say? This law said that the statement of this law, when two element combine. I know. So statement I'm not writing, just I'm giving you. Suppose when two element combine, one element is carbon, it is combining with the oxygen. Okay, O2. So it is going to give CO, 1/2, right? And the second one is it is also combining,
3
but
plus O2 is
uh, okay, wait. Let us do fixed mass. We have to take any of the compound we are taking now. When one element combine, two element combine with the fixed mass of the third element, then their ratio is always constant.
there
Okay, hold.
hydrogen, oxygen, water, hydrogen, oxygen, hydrogen peroxide.
Oh, very good, very good. Everything you are knowing, yeah, intelligent. So H2O, and you are saying that is H2 plus O2. You are saying that is hydrogen peroxide. So one is the fixed. Here is H2 is the fixed. This is also fixed. So fixed means 1:1. Nothing to do with that. So which
Yes,
one
sir.
we have to
So we
see?
have to take the ratio of what is not fixed.
So this we have to take the oxygen in the H2O. So O ratio of O in H2O with that is O in what that is H2O2. So here is how much is there 16 and here is 32. So 1:2. It is also going to be what simple whole number ratio. Is it okay? Now let me check you the compound. If I am treating the S plus O2, it is giving some compound. Again, it is going to give S plus O2. Okay, S plus O2. Or you can see the two compound it is going to form. One compound is the what SO2 and another compound is SO3. So in the what law it is following and what the ratio are you expecting?
So following multiple proportion only, sir,
Uh,
here ratio would be 32 is to 16 into 3 minus 48.
hmm.
8, this will come 2, 3. 2 is to 3.
Okay, very good. One more compound, last one, let us see. See, nitrogen also undergoes the law of proportion. Which one? Multiple proportion. It combined with the oxygen, okay, half oxygen, so it formed that is NO. Many examples you will find. Then again it combined with the, okay, this form that is compound is what is called N2, NO2, NO2. This is there. Then it gets this is the fixed one. Okay, there are many others are there. I'm giving only easy one. So here also it is going to follow the law of multiple proportion. Is it?
So 1 is to 2.
1:2. So this is what next one is law of reciprocal proportion. Law of reciprocal proportion. Reciprocal proportion. Okay, this law also tell the similar information about the like the law of multiple proportion. Here three elements are there. Okay, here they are saying A, B, and C. These three elements are there. Okay, one element is fixed. One element mass is fixed. Mass is fixed. That is first one. As like the previous law, one element mass is fixed. Two element, two element, two element mass vary. They are saying mass vary. Two element mass vary. Now, the third point, what is the important one? Third point, the ratio, they are saying the ratio of masses, ratio of masses in which, what they are saying, in which third element, second and third, here that is this one. So I am writing that is second and third element combined. Second and third elements combine with second and third element combine. Beer, yeah, either here this will come beer simple whole number ratio. Beer simple whole number ratio. Simple whole number ratio with. See here the statement is very difficult. With which one? Simple whole number ratio with which element? That is with the
First
element.
element which remains compound. Constant.
Thank you very much. With elements having fixed mass. Having fixed mass. Having fixed mass. So you will find that is that statement is quite difficult, but for understanding it is okay. So let me try to deal with this one with the example. See, if I will take the compound carbon, we can take. Okay, let us see the carbon I am taking. One oxygen here. Okay, carbon I am taking and sulfur I am taking. Okay, is it visible in your skin? Na? Hmm. So if suppose these terms, if I will take, so what is there? CO2. This way, it is the SO2. And now the two things. What is there? Mass of oxygen. Can you tell me which one mass is fixed? Oxygen mass is fixed. Yes or no?
Yes.
So here the one element mass is fixed. That is we fix this one. Two element mass varies. Like carbon mass is how much? Carbon mass is if you'll find that is 12 is there. So 12 ratio 32 is there. And here is how much? 32 ratio 32 is there. 32, 32. Now, read out the statement. The ratio, here they are saying that statement here, the ratio of mass in which second and third element combine. So these two elements combine together. So what it is going to give? CS2. Combined. Bear simple whole number ratio with the element having fixed mass. So which one is having the fixed mass? Oxygen. So oxygen I am putting in the center. Okay. And here is the with the oxygen here, the ratio is how much is there? 12. This is the here is the oxygen. If I will simple ratio, let us take the simple ratio. Here will be carbon, here is oxygen, and here we will take the sulfur. So, or because the two ratio will come. One time will come with the carbon oxygen, another time will come the carbon sulfur. Okay, two ratio will come now.
Yes.
So two ratio will come. So little bit I'm erasing here because the place is come less. Oh, here is. So firstly fixed with fixed one is on top. Fixed with the first variable. Okay, variable. Then it will go again fixed with second variable. Okay, second variable. So fixed one is the oxygen. If you see, if I will take the oxygen, okay. So oxygen I am not putting in the too much simple. I am putting in the whole what it is coming. So 32 is there. First variable is 12. Then again, if you see, the fixed one is the 32, and the next variable is what is there. That is again 32. So it should come 2:1. You check out how much is coming. So 32 by 12 total divided by 32 by 32. So if I will solve it, so 32 multiply by 32 divided by 12 multiply by 32. This is cancel out. 32 by 12.
8:3.
Here, wait. 32 and sulfur is 32. It is coming how much? 8 by
Sir, 8/3. Sir,
8 by
cancelling by 4, we get 8/3.
8 by 3. So this way you will get the always we are going to get the simple whole number ratio. Let me check in the book if anything other are there also.
Sir, in NCERT it is not there.
Yeah, in NCERT it is not there. So there we have taken the fixed mass. Okay. So this is how we have to understand. Okay. This is correct one. So next one we are going to study multiple proportion. Reciprocal is also. I'll give some more example on the basis of reciprocal proportion, right? Okay. Carbon. Let me check you if any other example if I will find in the book. Okay, not there. Let now we are going for the what next one is there. Suppose you are going the Gay-Lussac's law. Can you tell me Gay-Lussac's law?
Sir,
Gay-Lussac.
that when gases combine or produced in chemical reaction, they do so in simple ratio by volume, provided that all gas are at same temperature and same pressure conditions.
So already you are knowing. So that is what the you are talking about reactant or product also.
Reaction.
Earlier the law was given only for the gases combined in the definite fixed whole number ratio or the simple whole number ratio. Now this goes to the product also. So product, what the reactant, all the reactant and product will be the simple whole number ratio. Suppose here the mole, if you are checking that is 1 mole are there, here 3 mole are there,
One,
and
three,
the
two.
1 T through. So it is also coming, how much is coming? Simple whole number ratio. This is what? Simple whole number ratio. So always any of the gas you can combine, you will find that is simple whole number ratio with the case of reactant, all the reactant and product. Anyway, uh, but it should be the gases, not in the liquid. Suppose yeah, if I'm
Yes.
going H2 plus Cl2, it is going to give 2HCl. Hydrochloric acid is the gaseous form. This is also gas, this is also gas. So now you can see the ratio will be 1:1:2. So it is always going to be the simple whole number ratio. Any of the gases you can see. Okay. Suppose I am having CH4 gas is there. I am taking O2 gas. It is going to give that is CO2 and 2. It will give water also, but we are not bothering about the water because it is the liquid. So whatever the liquid are there that we have to skip out. And here is 2. So here is the carbon
Sir, we are
dioxide
ignoring the liquid, taking only the gaseous part.
only. Yes. Okay, they have given for the gaseous Gay-Lussac's law of the combining gaseous volume. Okay, so I am combining in the term of what mole. You can combine in the term of volume also, but you will get the simple whole number ratio. Let me check you here. So this is 1:2:1. Now 1 mole is equal to how much? 1 mole is equal to 22.4 liter. 1 mole
4
is equal
liter.
to So here is the 22.4 liter. Then here is 3 into 22.4 liter and 2 into 22.4 liter.
67.4.
Now you see this all will be cancelled out now 24, 24, 24. So 1:3:2. You are going when even though it is combining in the term of volume, but you are going to get the answer in term of what? Ratio will be always the simple whole
Ratio.
number ratio. Is it okay? Is it
Yes.
okay? Now we are having the Avogadro law. Avogadro law, the very simple one, Avogadro law, but this is very useful one. Where you will, when you will
Yes,
study
sir.
the limiting reagent or any of the mole concept problem, how much amount of the gas is going to formed or how much amount of gas is going to combine, how much amount of gas is going to be left. This all things will going to be getting from the Avogadro law. What the Avogadro law is saying? Avogadro law is saying at fixed temperature, if you are fixing the T and P, I know T and P, fix the temperature. So
Fixed
what the,
temperature and pressure, equal volumes of gases have equal number of moles.
so B
Molecules,
equal,
sorry.
yes, B equal to N, it will be the, okay. Mole is also correct. There is no problem. Mole and
Yes, sir.
molecule, For this law implies for the little bit good only. So either you say B is equal to 1, actually it is the proportional, B proportional to 1. So
Yes, sir.
what we,
Proportional.
B is equal to, we write the Kn. So K is
K.
equal to B by N. So this is there. Okay. Now what the point here, the important point, suppose the volume is, I have fixed the volume. Okay. I have fixed the volume. Okay. And the volume, how much I fix, this is the 22.4, or you can take little bit more. Okay. Here is the, I am taking 44.8, the simple one. This is the liter, 44.8. Here is also 44.8. This is also 44.8. This is the 44.8 and 44.8. Here they are saying this is, they are the, all the volumes are the fixed. Now, either you take the CO2 gas, or you take the NO2 gas, or you take some Cl2 gas, or you can take H2
Cl2
gas,
and HCO2.
or you can take next one H2, or you can take the NH3. Any of the gas. Now, whether
Sir,
they are
everybody is having 44.8 liter means mandatorily they are having two mole only. That is 22,
two,
12.04.
yes, yes, yes. But here you see the atomicity is here. How much is there? 3 is there. Here is
Atomicity
also
3.
3. 3. Here is 2. Here is
2.
how much? 2. Here is 2. Here is
2, 3.
NH3. No, it is the also, it is having the 4. Okay. Suppose you have taken the one more 44.8, and here is that is CH4 you have taken. CH4. So atomicity is 5.
Right.
Now the size wise it appears to be that is the CH4 is 5 atoms are there, so it should be bigger molecule. But when we consider in the gaseous volume, the molecule considered to be sphere one. It is always considered the point size is spherical molecule. So whether how many atoms are there in that one, that is not going to be count in the volume. Okay. So the volume is irrespective to the atomicity. Volume is irrespective to the atomicity. Means number of mole you will find that is 44.8, and molar volume you very much 22.4. So every cases, because molecular mass we are not taking, number of atom not taking, so it is always going to be what, 2 mole. It is also going to be 2 mole. Here is 2 mole, 2 mole, everywhere 2 mole. Number of molecule, if you are calculating number of molecule, okay, not atoms, atoms will be different. So
Yes, sir. Number of molecules.
so n into
2
Na,
into
Na. So everywhere it will be what? 2 Na. Everywhere what is number of molecule will come 2 Na. So it is fixed. Yes or no?
Yes, sir.
Everywhere. So this was the law which was supposed to law of chemical combination over. What else? What next will come? Ajay, Ajay. What
Sir,
next?
next is mole concept, sir. Next is mole concept.
Mole concept. Okay.
We are
Let
having
us.
Dalton's atomic theory, then average atomic mass, formula mass, all that we are having.
Uh, okay. Let us. Firstly, you go with the Dalton's atomic theory that you must be knowing actually. Dalton's atomic theory. Okay. This theory is somewhere, giving the elementary information about what this give the first. This was not the experimental base. You must be knowing. Just it was the imagination base. And nowadays, in the current scenario, this law is completely out of the context. Means the
Yes, sir.
most
This is
of the
not news.
means most of the point got failed. Like what the point are there? Some are the feasible nowadays, like the atom is spherical, that is spherical. Atoms combine to form compound, that is also correct one. Okay, so some points are there, but major point what he gave, he claimed that is failed.
The
Okay,
matter consists of indivisible atoms.
that is correct one. That is failed one. So for
Yes,
let
sir.
us
That is failed.
so he said matter consists of, okay, no, fine particle,
Indivisible atoms.
minute particle. Okay, let us try to write individual atom. That is also correct. Indivisible. Okay, like that is correct one. Means nowadays we are breaking the atom into what?
The
Electron, proton,
neutron,
neutron.
proton, electron.
So okay. Now the second point he said, this point is feasible
All atoms
nowadays.
of a given element have same chemical,
Uh,
same identical properties, including identical mass.
yes. One more point he added.
Different
Atoms
elements,
come.
different mass.
Okay. Atoms can't be seen by naked eyes. That he said also. This is nowadays also confirmed. Atoms you cannot see by naked eye. This point was given by actually the Daltons only. But this point is not that much of the practically applicable. Everybody knows that is atoms we cannot see. But this point was actually given by Daltons only. At that time also people were seeing anything, but if they were not able to see the atoms. So that is okay. Now, what the point you are saying, the next one is atoms combine to form compound. This is also the correct one. He
Yes, sir.
said,
This is correct.
this is also correct. Atoms or molecules. Atoms or molecules combine to form compound. combines to form compound. To form compound. So this point is also the feasible one. There is no problem in this one. Okay. Next one is there, Sanoy, the point which gets failed. That is what you are saying. He said atoms of same element, whatever, same element are, what he said, similar by mass. Atoms of same element are, what is a similar,
Identical in properties, including mass.
similar, uh, atoms of same element are similar by mass. This is what the point, including mass, he said. But what we get failed after discovery of what?
Isotopes.
Isotope. Failed after discovery
Sir,
of
it also
isotope.
says that atoms have different elements, different mass, but that is also failed due to isobars.
Discovery of isotope. So this point you know, na? So I am not going for the next one. Already you know. Fifth point you already know. I know for the case of isobar, he said that is atoms of what he said. Atoms of, he said, that is the different elements are differ by mass. But isobar, in case of isobar, it get failed. Yes, yeah, no.
Yes.
So no need to write now. Okay. So next point, this Dalton theory you know very well, like from the ninth standard, and from this no problem is going to ask in the that is competitive track. What is the next point? Next topic you check in your
Atomic
book.
mass. Atomic mass.
Atomic mass. Atomic mass. Atomic mass. So atomic mass means how to define. There are many ways to define. Okay, atomic mass unit. So AMU is equal to 1 by equal to 1 by 12th mass of
Twelfth
carbon
of
12.
mass of carbon 12 atom.
1 by 12th mass of carbon 12. That is one way is there. Now, this is the one atomic mass unit. Here is the important point which we have to understand. What the point which we have to understand here, you see. Atomic mass means, it means any atom is how many times, how many times, how many times, how many times heavier, heavier than what? How many times heavier than
1/12 of the mass of
1
carbon.
by 12th mass of carbon. Mass of carbon. So this way, suppose if they are talking about the hydrogen, mass of hydrogen. So mass of hydrogen is 1. So it is equal to 1 by 12 mass of carbon 12. Yes, yeah, no. Carbon 12. So
Yes.
this 12 can cancel out. So 1 equal to 1. Okay. Now if I will talk about oxygen, oxygen is 16. So this oxygen is how much? 16 time. This is that 16 time heavier. Yes, yeah, no. Heavier than
Yes.
what? 1 by 12 mass of carbon 12. Mass of carbon 12. This is.
4/3 times heavier than carbon atom.
Ha. So this is all about the atomic mass. So atomic mass we study this format, that is much easy. Is it okay? Okay. Now the question sometimes they ask the definition in this form. Okay. Our next one is there. We are having the molecular mass. Any other things? Molecular mass. Yes, yeah, no?
No, sir. Molecular, sir, we are having average atomic mass, then
Every,
molecular mass.
okay, thank you very much. Average atomic mass. Here you see average atomic mass. Okay. If I will talk you average atomic mass, how we study the average atomic mass. Okay. This is the important one. On the basis of this one, the question in the JE also come, NEET also come. This is the important one. Okay. Now, when you talk about the average atomic mass, how can we study average atomic mass? So,
Sir, we have a formula that percentage abundance into atomic mass 1 plus percentage abundance in atomic mass 2, that will go on to percentage abundance and atomic mass of whatever we are having divided by 100. We'll get the average
okay.
atomic mass.
So that is average atomic mass of, I'm writing atomic mass of carbon. Suppose carbon. So carbon is found in the 3 isotopes. Okay. C12 is there, C13 is there, and C14 is there. It
40.
found in the some percentage it is having. Okay, it is also having some percentage. It is also having some percentage. So what is we are writing AVG is equal to, that is the first mass of first isotope. Mass of what is there? First isotope. This is mass of first isotope
isotope into percentage.
multiply by its percentage and a percentage abundance. Then mass of second isotope. Mass of second isotope. And after mass of second isotopes, then we will write the its percentage, and all isotopes are considered to be 100. If you are adding out the percentage, it is always going to be the 100%, right? Yes or no?
Yes.
So on the average atomic mass, because the data is required now, so I'm giving you problem from the book only. Let me write the problem and you try to solve that one. Give me 1 second till I find the problem. Mm, In NCRT itself, there are 2, 3 problems they have given. Have you checked that one? So now, have you checked the problem in the NCRT book? Let me bring out the my tab. No? 1 second, 1 second. Tanu, are you there? Okay. So we are having the chlorine 35 and another is there chlorine 37, right? Its
Yes.
percentage they have given percentage 75.77 and its percentage 24.23. And here is they have given molar mass. Molar mass here is already given, molar mass is the same. Okay. So you
38 that is
calculate.
it.
That is already written. Okay. Here is they are asking average atomic mass. Can you calculate or
Sir,
should I?
here one thing I want to ask, sir, here this percentages, sir, we can so these percentages we can round off this
Uh,
one we will have 76 and this one 24.
yes. You can do. You can do. It will
Because
come
that
on.
will make it easy actually.
Actually, in competitive track, what we do, we don't do the calculation. Okay, simply we memorize
Yes,
the
sir.
we simply memorize the atomic mass. So
So
that
this
gives.
I already know. So this will be 35.5.
So
But sir, if
value
anything
will
else
also
comes
come.
from the
You solve it. The value will also come the same. Value is also going to same. One more I am searching. I'll give you. I got that one also. There are so many problems, but
Certain.
It is coming na 35.5. Okay. See, now what you are studying now, you know most of the things you know very well. Okay, not required, but let us finish once. Then when you are solving the competitive track problem now, then only you will find some interesting things. Getting my point? Hello, Sanoy.
Yes, sir. Yes.
When you solve the difficult problem, then your mind will be it will say that is the class is okay. Okay, now what we are studying, very simple things we are studying, right?
Sir, then we
So
can start doing the problems.
so firstly you finish the chapters as one more class it will take, then it will finish, then we'll do the problems for other need. Okay, so
Sir,
I'm say
you told sir after 15th we will be having classes Tuesday and Thursday also alongside this Sunday class 5 to 6 p.m.
15 so okay. Tuesday you can join 5 to 6. Tuesday I am having time. No, Tuesday I am having time, no problem. So so no, you join again na? It is going to be over 40 minutes, so
Yes, sir. Yes.
again wait, let me finish the I'm sharing that one.